Good evening to all and welcome to Byju's exam prep. So hope I'm audible as well as visible to you all. Right. So I am Basavaraj. I'll be taking ecology and environment classes for the evening batch. Right. So please confirm that I'm audible as well as visible to you all. Done. Okay. So we'll start the ecology and environment session. Now, when we talk about this ecology and environment session, one thing you should keep in the mind that this plays very important role in a UPSC examination, whether it is Indian Forest Service or whether it is UPSC, IAS and IPS, because simultaneously when we see them, both are taken with the one prelims as well. So it plays a very important role in the prelims aspect. Not only in UPSC, but even in case of all NDA exams or CDS exams, Group C exams, any exams you take, SSC, Staff Selection Commission, or it may be Combined Defense Service Examination, or it may be National Defense Academy, any exams for that matter. This ecology and environment plays a very important role. Many questions you can expect from this ecology and environment in prelims, not less than 10, 15. Sometimes it may be 20 as well. So at least more than 10 questions you can expect in the prelims. Apart from that, this is very important even in the context of your mains examination. Now in the mains examination, you can expect around 2 to 3 questions which are linked directly with ecology and environment. Maybe groundwater issue, maybe pollution issue, maybe global warming and climate change issues. So you can expect good amount of questions in the mains examination. And apart from that, this also plays an important role when you reach to the Viva session, that is personality test. So there also you will find the major concern of ecology and environment. And this is found in humanities, engineering, as well as normal education curriculums. It is base of all those because entire earth is facing the problem associated with the ecology and environment concern. Every country, it can be developed country, developing country, poor, rich, industrialized country, every country is affected by the concerns of this, and every section of the people is affected by this. Agriculture, industries, service sector, all the sectors, primary sector, secondary sector, tertiary sectors, all sectors are affected by the concerns of ecology and environment. So hence it has played a very important role in everybody's economic activity. So hence you have to be very important in understanding that whatever contents are there in ecology and environment, they play an important role not only in examination but creating awareness among all the people with reference to the concern of the subject. Right, so it is very important in the prelims as well as mains plus viva. You should not surprise if there is an essay which can be asked from ecology and environment. Essay of, say, maybe impact of climate change on agriculture, or maybe associated with global warming, calamities, etc. So essay can also be expected from this. It is a very small topic, small concern, but huge potentials are there. But when you talk about ecology and environment, we refer this as an interdisciplinary subject. Interdisciplinary subject. What does it mean? It means that it is something which is associated with the concern of geography. So geography is very important here. You should be good enough in the basics. Then third thing is when you talk about its perspectives, some of the topics are overlapping with S&T. Some of the topics will overlap with S&T. And you have something called as agriculture sector. So even in agriculture sector also, we find ecological concerns will be there, like land degradation, pollution perspectives, water pollution, etc. So it is seen in all the sections. So as it is found in geography, as it is in SNT, as it is in agriculture. So hence, you should not surprise if the question from ecology and environment, a sub part of that appear in GS paper 1, GS paper 2, and GS paper 3. It is not mandatory that it should be only in GS 3. Sometimes a part of that can be reflected along with the main question of geography. So hence, you should be prepared in all the context of ecology and environment. So hence, I say that it can be in paper 1, paper 2, as well as paper 3, right? So don't study your aspects keeping paper 1, paper 2, and paper 3. You should make a holistic approach. You should make a holistic approach so that if that topic is asked in any paper, you have to be in a position to write it. So that is where an approach becomes a simplified one, right? Now, when we talk about this, first thing is what has to be studied here. What is the scope of this subject? Now, when we talk about the scope of this subject, here you should come across certain aspects, right? So when we say how GS2 is connected, GS2 in the sense, when we talk about any concern of taxation that can be linked with the ecology and environment, any concern with the programs which are linked with the ecology and environment, so you will find them in even agriculture sector, and agriculture overlaps with economy, agriculture overlaps with social issues. So some parts will be there where we find overlapping. So hence we say it is a multidisciplinary approach. Now, what has to be studied here? What is approach has to be done here? Now, in the present aspect, we say due to increasing of the population, as the population is increasing, plus rapid urbanization or unplanned urbanization, urban areas which are increasing, plus rapid industrialization. So all the three, increasing population, unplanned urbanization, rapid industrialization, all the three are responsible for overexploitation of resources. Overexploitation of resources. Right. Now, when there is overexploitation of resources, maybe it is land resource, maybe it is water resource, maybe it is forest resource, maybe it is animal resources. So overexploitation of resources are there. And whenever there is overexploitation of resources, then these resources will degrade. They will degrade. And the moment when they degrade, their productivity decreases. And they are responsible for creating many issues. They are responsible for many issues, like it can create the global warming, what we are facing. Issues like global warming, climate change, land degradation, pollution, right? So many such issues will arise. Loss of biodiversity. So many such issues will be there. And this affects the entire earth. So hence in this regard, it is very important to understand the present state of the natural resources. Understand the present state of the resources. Plus, not only understanding that, we have to make an effort in protecting and conservation of the resources. Protection and conservation of the resources. Right. So we have to understand how we have to protect them, what way we have to conserve them. Along with that, we should also understand the issues arising out of this. Issues arising out of degradation, like what are the impacts of the issues? Impacts of the issues. Now, impacts are at present we are having a shortage of groundwater. So that is an impact of over exploitation of groundwater. Air pollution, that is an impact of over exploitation of the forest resources. Land degradation, desertification, so those all are impact of over exploitation of the resources. So we have to understand the impacts of them. What impacts are there on livelihood, people, and the earth, in fact. So we have to understand these impacts, and we have to make an effort in protecting and conservation of the resources. Now, when we talk about the protection and conservation of the resources, you should remember that this protection and conservation can be done at two levels: national level and at international level. So this can be done at national level and this can be done at international level. Right. So hence, we will be having many such legal aspects, conventions, protocols, etc. So we have to make an effort in understanding legal aspects, that is acts, national laws, national acts, Wildlife Act of 1972, Environmental Protection Act of 1986, Forest Conservation Act of 2022. So we have to make an assessment of these acts, that how these acts will help in protecting and conserving the resources. Plus at the international level, we have many agreements are there. We refer them as conventions. And also we are having protocols. So conventions like Minamata Convention, UNFCCC, United Nations Framework Convention on Climate Change, Convention on Biological Diversity, United Nations Convention on Combating Desertification, right? Stockholm Convention. So many conventions will be there, and these conventions are something where international agreements are there, where the countries make their efforts in protecting and conserving the resources. So we'll be taking these along with the topics, what the topic talks about and what are the important conventions are there. So we'll take up them along with the topic. So this is what you have to keep in the mind. So when you're reading ecology and environment, you have to understand what is the topic. Second, what is the present state of that resources, how it is benefiting humanity, what are the issues it is facing, and what are the impact of the issues. After that, how the policies will help us to protect and conserve them. If you keep this format, I don't think you will have any difficulty in answering any question which is asked in UPSC examination. I'll repeat. It is about understanding the resources, how it is overexploited, what is the issues associated with the degradation of resources, what are the impacts of that: air pollution, water pollution, desertification, global warming, climate change, groundwater depletion, everything you have to make an effort. Then how you can protect and conserve them. So this should be kept in the mind. So this is what the syllabus says: national approach, international approach. And these approaches are done by keeping certain institutions, certain authorities. So we have to understand certain authorities. We have to understand certain institution which plays an important role in protecting these paths. So this is called as the scope of the subject or syllabus of the subject. Now, next aspect is that how to cover that. What should be the strategy? Now, when we talk about strategy, you have to depend on NCERT, class 12th, last four chapters of class 12th, and class 11th, beginning chapters of biology. So they will help you in understanding certain basics. They are not the complete, but they will help you in understanding the basics. Keep this in the mind. Along with that, refer the PPTs which I'll be providing. I'm not telling that my PPTs are the best, but when you're attending the classes for 10 days, you will have complete idea, a holistic approach and a flow, and that flow will be easy for you to remember for a longer period of a time. So along with that, keep the PPTs as reference. PPTs as references, right? Biology textbooks, class 12th, biology, class 11th, beginning 4 or 5 chapters. PPTs you take. Plus, magazines, what you have to depend is, one is Geography and You magazine, Geography and You, and then Down to Earth magazine. Down to Earth magazine. And these magazines are very important. These magazines are very, very important, not only for S&T, even for geography, even for ecology and environment. Right? So here we find everything you will find included there. Yes, disaster management is also overlapping with that. So when you talk about cyclones, when you talk about heat waves, cold waves, so we find overlapping aspects are there. So hence generally we say it is a mix of all the subjects. So if you are good in geography, then this will become a cakewalk. If you are well aware about the terminologies, this will become a cakewalk. It is very simple, right? So these magazines you have to understand, and these will be the basics for your analytical parts in geography, in disaster management, S&T, as well as the concern of ecology and environment. Is that clear? Then apart from that, apart from that, right, apart from that, you have to depend on reports. Reports. So reports which are given by important institutions like National Oceanic and Atmospheric Administration. Like recently, the report has been given for World Air Parameters, IQAR reports, or the report which is given by NASA, National Atmospheric, right? So it may be from NASA, National Oceanic and Atmospheric Administration, Aeronautical Space, or maybe from ISRO, maybe from the national policies. So you have to depend on the reports. Many reports are there. Maybe from UNFCCC. Sometimes UNFCCC also releases the report. Reports are released by United Nations Environment Programs. We'll see some reports. We will see some reports so that it becomes easy for you to analyze which reports has to be done. So there are thousands of reports, but from that you have to read at least 10-15 reports. And these 10-15 reports, they will help you to analyze all the prelims as well as mains questions. So as we continue, I'll explain which reports are important and how to go with that. Right. Now, once you are having these many datas with you, once you have these many books, you have to always remember that the approach is in the context of this ecology and environment. More facts-based questions will be asked. Facts, datas will be asked. So it is more about memory game. Facts will be asked. So we say factual parts. Factuals will be there. Plus, concepts are also there. Concepts are also there. Concepts like greenhouse effect, albedos, how it affects each other. So we have to depend on facts, concepts. Plus, a huge role of current affairs is there. Now, as a safer option, if you are preparing the current affairs of last 2 years or at least 1.5 years, that is ideally feasible. At least 1.5 years. Right. So ideally, 1.5 years, current affairs are important. Now, down to earth and geography and you are very simplified ones. So once you are good enough in the concepts, I don't think you will have to make more reading on that. One glance is sufficient for that. One glance is sufficient because the topics which are covered in geography and you may not be same in the down to earth. So there will be variation on these two. So once you read that, you will come across the terms and you can make selective reading of the topics. You can make the selective reading of the topics. Entire magazine is not important. You can select the topics and read them. Selective and reading them. So this is some rough idea about what should be studied and how to make. Facts are important. Reports, data are important. Concepts are important. Then current affairs are important. Then last and not the least is applications of all the concepts in the present scenarios. Applications of all the concepts in the present scenarios, including examples. So applications are significantly asked in mains examination. Concepts, application, and example. So this you should keep in the mind. So whenever you are making notes for ecology and environment, please keep these things in the mind. Any ministry websites you will get from PIB. So not go detailed about ministries. You can fetch the data from PIB. You can fetch the data from PIB. Don't waste much time in going with the ministry website. Don't go with that. So PIBs is more than sufficient, right? So reports you can read from the data which are given in current affairs, like every once in a month or biennial. We may find once a report is released once in a 2 years, or sometimes every year also the reports are released. So you can take the reports which are important. Every current affairs will have that. Every current affairs, when you're reading, you will find across them. And if they're relevant with your topics, once we complete the psychology and environment, then you can select the topics and read them. Not all the topics are important. You can make a selective aspects once it is done, right? So once it is done, then it becomes easy. So don't get worried about that. So when I complete a course there, then you will understand what reports are there, right? So this is the approach what you have to keep in the mind, right? Now, keeping all these things in the mind, we will start the ecology and environment class. Don't worry about report names now. Just leave it. Understand first the approach. All, if you try to fill it at one time, then you may not digest that. It is an approach. So 10 days classes will be there. So you will be having a good amount of the knowledge-based part. Now, concept of ecology. Now, when we talk about the psychological perspectives, in geography, you have studied something called as landforms, plate tectonic theory, right? Then we have studied about something called as subduction, abduction, mountains, formation of landforms, fluid landforms, alien landforms, characteristics of the landforms, mountains, soils, etc. Right? How these have been formed, how they have been changing. All this you have studied in your geomorphology. Geomorphology, Earth and its changing pattern. And that study is referred as the first sphere of the Earth, called as lithosphere. First sphere of the Earth, lithosphere, where you are completely understood that in the context of geomorphology, plate tectonic theory, continental rift theory, sea floor spreading concepts, rocks, characteristics of the rocks, soils, characteristics of the soils. Apart from that, landforms which are created, nature of the mountains, all this you have studied in the lithosphere. After that, you have made an effort in understanding what we refer them as the composition of the present atmosphere, weather, climate, fundamental concepts like temperature, pressure, precipitation, winds, and atmospheric phenomena like cyclones, anticyclones, thunderstorms, right? All this you have studied in the second sphere of Earth, called as atmosphere. So this is called as the second sphere, atmosphere. So lithosphere is the first sphere, atmosphere is the second. Composition, winds, wind patterns, pressure gradient, cyclones, anticyclones, all this you have studied in atmosphere. Then the third sphere is hydrosphere. That is oceans, water bodies, ocean currents, movement of ocean currents, thermohaline circulation, UNCLOS, United Nations Convention of Law of Sea. What are the benefits? What are the boundaries? All this you have studied in your hydrosphere. It may be salinity part, it may be density of ocean part, it may be temperature and how it impacts, it may be about the tides, it may be about ocean resources, which benefits many humanity. So all this you have studied in hydrosphere, which is referred as the third sphere of the Earth. All these are packed aspect of geography. Now, any area where these three overlapping of these three spheres on the Earth, where they meet, that is an area where there is a possibility of life. This small area where they overlap, it is an area where there is possibility of life. Possibility of life is there. And we refer that as biosphere. We refer this as biosphere. Which is referred as the fourth sphere of the earth. Biosphere, which is referred as the fourth sphere of the earth. And always remember that the biosphere is affected by lithosphere, it is affected by atmosphere, it is affected by hydrosphere. So basics of all the three spheres are important in understanding the ecology and environment, right? So it is a region, we refer that as biosphere. So in this biosphere, the small area where there is a possibility of life is there. So this biosphere consists of living components. It consists of living components, and we refer them as biotic factors. Biotic factors like plants, animals, etc. Like flora, that is plants, animals, etc. Living components, right? And this also consists of non-living components. Biosphere also consists of non-living components. And non-living components means abiotic factor. Abiotic factors. And abiotic factor includes, example, the soil, temperature, water, light, etc. So living as well as non-living components, right? Now, apart from that, biosphere consists of living as well as non-living components. So these living components and non-living components, they exist in their physical part. So the physical space surrounding the biotic and abiotic components is referred as environment. So the physical space which is surrounding the biotic and abiotic component is referred as environment. So environment refers to the physical space. It is simple. Now, if you are visiting any temple, then you say the environment is very peaceful. It means that the surrounding area is very peaceful. So that is your environment when you are in the temple, or when you are in the mosque, or when you are in any areas, or in the church. But the moment when you enter into theater, or when you enter into IPL stadium where the match is there, you'll find the noises are there. Then you say that the environment is very noisy. So it means that the physical space surrounding you is very noisy. So hence environment means the physical space surrounding you. Environment means the physical space surrounding you. So hence environmental studies are important. The physical space surrounding us is very, very important, and they affects us because the area in which we are staying, the air is polluted, it will affect us. If the water is polluted, it will affect us. If the land is degraded, that will affect us. So that environment means the physical space in which we are, where the living and non-living components exist. So please keep this in the mind. So environment is the physical space within which the biotic and abiotic components are there. Is that clear? Now, next aspect is, when we talk about the living and non-living components, they always have an interaction. So the biotic and abiotic components, they always have an interaction. Now, what do you mean by interaction? See, when two friends, A and B, when A and B interact, what they will do? They will exchange ideas. They will always exchange ideas, right? So interaction means exchange. So hence, in this aspect of biosphere, there is always an interaction or exchange which is done. And this exchange is between biotic components and also abiotic components. Exchange is between the biotic components and also abiotic components. And what is the thing they exchange? They always exchange two important aspects. They always exchange two important aspects. They exchange, the first one is called as energy. Energy is exchanged. Second one is they exchange matter or nutrients. They exchange matter or nutrients. So these are the two things which are exchanged in the biosphere between the biotic community along with abiotic community. And the systematic study of this, when we study that exchange of energy and matter, we refer this as ecology. We refer that as ecology. So ecology is a systematic study of the exchange of energy and matter in the biosphere, and that is referred as ecology. So remember the term ecology, then environment, the physical space in which we are there, we refer that as environment. Is that clear? Now, next aspect is, when you talk about the study, entire biosphere cannot be studied at one go. Entire biosphere we can't study at one go. So hence we make a sample space of that. We take a sample, or we take a unit to make the study, a small portion of that. And this unit which is used to study is referred as ecosystem. A sample unit which is used for the study is referred as ecosystem. Example, it can be forest, it can be desert, right? So any such sample units which is taken for the study, we refer that as ecosystem. So biosphere, biotic, abiotic communities, and the ecosystem. So hence ecosystem is referred as functional unit of the biosphere, or functional unit of ecology. Now we'll try to understand something more on this ecosystem. Right? So ecology is the systematic study of the relationship, interactions between the biotic components and also with the abiotic components. So it is the systematic study of the relationship, interaction, exchange of energy and matter or the nutrients. Right? Now, bit more on this ecosystem. Now, when we talk about this ecosystem, if you take this as an ecosystem, this ecosystem exchanges both energy as well as matter with the surrounding. It exchanges energy and also it exchanges matter with the surrounding. It exchanges both with the surrounding. That is surrounding area. And hence, ecosystems are referred as open system. Ecosystems are referred as open system. So any system where the exchange of both energy as well as matter is there, both, they exchange both energy and matter, both with the surrounding space, with the surrounding environment, we refer that as open systems. So hence ecosystems are referred as open systems, where they exchange both energy as well as the matter. Next, when you talk about the aspect of ecosystem, the first one is the size of the ecosystem. The size is not fixed. It can be very small. Take an example of garden which you have framed or which you have created besides your home. Agricultural field, that is also ecosystem. Amazon forest, which is spread in many countries. Pond, very small. Ocean, very big. So hence, when we talk about the size, its size is not fixed. Its size is not fixed. It can be very small, like pond, or it can be very large like Amazon forest, which is spread in many countries, or it can be large like Amazon forest, which is spread in many countries. So hence its size is not fixed. Size is not fixed. Then second aspect is that about the energy. Now the exchange of energy is also not fixed. We don't know how long the ecosystem will survive. So the time of exchange is not fixed. Is not fixed. Because we don't know how long a human being will survive, how long the tree will survive, how long that organism will survive. So when they are surviving, then only the energy is exchanged. So we don't know how long the ecosystem will survive. All the ecosystems or any animal, they can survive for few days or sometimes few months or sometimes many years. Many years together they can survive. Take an example of Amazon forest. So it is surviving there for thousands of years. A pond which was existing, maybe because of human activity or maybe natural factors, that pond has been collapsed. That is, still nothing has been seen there. No aquatic plants, nothing is there in that pond. Everything has been damaged. Any animal which is making the flow of energy, we don't know how long this animal can survive. So hence the exchange of energy, the time of exchange of energy, maybe for a day, maybe for a month, maybe for years together. Time is also not fixed. This time is also not fixed. Size is not fixed. Time is also not fixed. So hence the ecosystems are referred as open and flexible. Ecosystems are referred as open and flexible. So we can say that ecosystem is a functional unit. It is open system and flexible. At present, we can say it is a functional unit, it is an open system, and it is a flexible. Right. So see, the definition we'll take up later. First understand the flow. Then we can conclude the definition. Right. So definition can be done when you are having a complex words, when you decode them into simplified terminologies. Is it clear? So it is an open system and ecosystem and flexible. Now, next aspect is these ecosystems. They can be of many types. So we'll try to understand the types of ecosystems. So these ecosystems can be man-made, example, agricultural field, garden, lakes. So they can be man-made, ponds, etc., or they can be natural. This is one way of classifying. Okay. Open system means any system which exchanges energy and matter with both the surroundings. So energy and matter is exchanged with the surroundings. Take an example. Take something called as when you are having a cup of a tea. When you keep the cup of a tea in the table or on the table, when it is not covered with any type of thermoflask and all, when it is open, the heat is exchanged with the surrounding. Maybe after 20 minutes, half an hour later, the complete water becomes cold, or the complete tea will become cold. That is one. Second, if you keep it for a day, 2 days, or 3 days, then the water will also shrink there. Maybe evaporation takes place, or maybe it will reduce its part. So we refer that as exchange of the energy as well as nutrients with the surrounding. Naturally, we refer that as open systems. Right? So they can be man-made or they can be natural. Then second way where we can classify them, which is most accepted, is when you classify the types of ecosystem as aquatic. Aquatic means water bodies, or we can classify them as terrestrial. So terrestrial means it can be forest, it can be desert, it can be grasslands, etc. We refer them as terrestrial ecosystems, right? Then when we talk about the aquatic ecosystems, again, they can be classified into two ways. Now be careful in understanding this. Aquatic means water bodies. Now we come across rivers, creeks, and streams. Now in the rivers, creeks, and streams, the water is continuously flowing. If you take lake, pond, etc., where the water is stagnant. So we have two types of aquatic bodies, flowing and stagnant, right? So if you take example of river, which is flowing, and we refer that as lotic ecosystems. Where the water is flowing. And we also have an ecosystem where the water is stagnant. Example, ponds or lake, where the water is stagnant. Stagnant water is there. So stagnant water, where we find, we refer that as lentic ecosystem. Right. Now, simple question is, if they ask in UPSC, basic observation. Now, if you take both the waters, river water and pond water, which is stagnant, now where do you find the incidences of water pollution is heavy, in the flowing water or the stagnant water? Which water will be more polluted, the lotic ecosystems or lentic ecosystems? Right. So that's how you have to understand. Perfect. Stagnant water. So hence they will never ask you stagnant or flowing. They will ask lentic and lotic ecosystem. So hence lentic ecosystems will be more polluted than that of lotic. Is it clear? So that's how you should remember the terminologies. So that's why when the river is flowing, if the river is made to stop, then the pollution level will increase in the river. Right. So hence you should be very careful with the terminologies. Lotic and lentic. So this is one way where you classify them. Is it clear? Then the second way where you can classify the aquatic ecosystems are, you can classify this aquatic ecosystem into something called as freshwater ecosystem. Freshwater, example lake, example river, etc. Freshwater ecosystem. Then the second aspect is where you can classify them as marine ecosystems, like oceans, sea, etc. Marine ecosystems where the water is saline. So we refer that as marine ecosystems. Example, ocean, sea, etc. Right. Now, in between these, we come across an area. Where we find a river. This is a river, which meets ocean. The river meets an ocean. Now, whenever the river meets an ocean, then there is two possibilities are there. When the river meets to ocean, what are the two possibilities? What it can create? Which type of landforms it creates? When the river meets ocean, what type of landform it creates? It can be delta or it can be estuaries. Perfect. It can be delta or it can be estuary. So it can create either delta or it can create estuary. Right. Now, if you see the water in the delta or estuary, it is a mix of river and mix of ocean water. So it is having the combination of both fresh water as well as salinity of the oceans. And this water is more saline than river water and less saline than ocean water. And such types of water where you find in the deltas, or estuaries, we refer them as brackish waters. Brackish waters. Is that clear? So brackish water means that where it is having the mix of the fresh water as well as saline water. So in the deltas and estuaries we find. So hence the third categories we refer them as estuarine ecosystems. Estuarine ecosystems where you have brackish waters. Right? So estuary means where there is not much of depositions are there. Now if you take the map of India, so we find Narmada estuary and Tapi estuaries. Estuaries are found in the west coast of India, and in the east coast of India we find deltas. In the east coast we find the deltas. Kaveri Delta, Krishna Delta, Godavari Delta, but Narmada estuary, Tapi estuaries, which are there in the east coasts and west coast, right? And these are the areas which are having the combination of both salinity as well as fresh water. So hence, estuarines are most productive, more rich in their productivities. So this is very basic things you should remember. So types of ecosystem can be man-made or they can be natural, or we can classify them as aquatic, terrestrial, and estuarine. We can classify them as aquatic, terrestrial, and estuarine. Apart from that, we can also classify them as lotic and lentic ecosystems. Right. See, the difference between estuary and delta you have already read in your geography, right? See, estuary is not a landform. Estuary is, when we say, it is where the river meets to the ocean, it will create a type of small deposits there, which are there, right? Now, if you see the definition, then we can put them into where the erosion has been taken and deposition is very, very less in that areas. Okay, so this is what we refer as a type of ecosystems, right? Then next we move on to components of ecosystem. What the ecosystems consist of? So the ecosystems consist of both the components, as I told, abiotic components and biotic components, living as well as non-living components. Now we have to make an assessment of these. In the context of biotic components, we have autotrophs, which produces their own food, heterotrophs, which depends on autotrophs. Then we are having decomposers. Within the consumers, there is a subdivision. They are primary consumers, secondary consumers, tertiary consumers, and the quaternary consumers. The hierarchies. We'll take up this later. But when you talk about abiotic components, in the abiotic components, we find the components like rainfall. Rain. In India, we are having monsoon rain. But in some areas, we have onshore, offshore, windward, leeward. So rainfall, which is responsible for water part. Then light, wind, temperature, etc. Right. So rain, light, wind, temperature, which are referred as climatic factors. Apart from that, all the factors which are associated with the soil, which is very vital components, all the factors which are associated with the soil, characteristic of the soil, thickness of the soils, pH value of the soil, we refer that as edaphic factors. So edaphic factors means all the factors associated with the soil and soil characteristics. That is, what type of soil it is, red soil, black soil, what is the pH value of the soil, whether it is plain area or whether it is having the slopes, right? So these all are very important in the context of all the soils parameters. Is it clear? So ecosystem has abiotic components as well as biotic components, right? Now, next aspect is we'll try to assess abiotic components and then we move on to biotic components. See, when you talk about pH is associated for any product, not only for the liquid, it is for any, where we say it is 0 to 14. 7 is neutral. Anything which is less than 7 is acidic. It is gauged on. So even in the human body also we say pH level. Is it clear? So when you're eating any food, pH values right? So it is acidic and the salt content which is determined in a very simple layman's language. Right, now abiotic factors, focus on understanding these. See, don't make in-depth analysis. So whatever I'm discussing, that is more than sufficient, and these all you are covered in your geography, right? So please focus on reading them, revising them, right? Now abiotic factors. So the moment when you say abiotic factors examples, they are light, soil, temperature, right, humidity, water, etc. So these all are referred as abiotic factor. Now these abiotic factors, when you have the data of longer term, say temperature, humidity, availability of water, heat, etc., when you have the data of a longer term, say 20 years or 30 years, what do you call that? When you have the statistics of a data which is accumulated for 20 years, 30 years, or 40 years, so that data which is accumulated, we refer that as climate. So can we say abiotic factors plays an important role in defining the climate of area? Can we say that? Right. So can we say that abiotic factors plays an important role in defining the climate of that area? So Himalayan climates are different, right? So hence abiotic factors, they plays an important role in defining climate of that area. So this is how we have to understand it. Climate of that area. Is it clear? Now, when we talk about the climatic conditions, the Himalayan climate and peninsular climate, do we find the same types of plants and animals exist in both the cases? When you see the climate which are there, if you see the climate of Himalayas, if you see the climate of desert, so you don't find. So hence we can say abiotic factors are responsible for the flora and fauna in that area. It means abiotic factors defines which plants can survive, which plants have adapted to the climatic conditions here. So hence abiotic factors are responsible for the confined flora and fauna in that area, or responsible for the flora and fauna. So hence we say abiotic factors defines the flora and fauna distribution. So abiotic factor defines the distribution of flora and fauna. So this is how you have to make your linkages. So once you know the abiotic factors, then based on that you can say what type of plants, what type of animals will be there. In the desert, different plants are there, different animals are there, because their factors are also different. So hence abiotic factors, even though they are lesser in the prominence, but they are very, very important in defining the climate and defining the distribution of flora and fauna. Is that, please keep this in the mind. Right. Now, next, when you talk about that, the first one is among them, the first one is light. Now, this light is very important because in the animals, light is important for growth, even in the plants also. It defines, or it is very important aspect in reproduction, the process of reproduction. It has some significant impact on that. Metabolic activities, reproduction, etc. So light plays an important role, even though it is a abiotic factor, but it has an important role. It defines which type of plants grows in which type of areas. Right. Now here, based on the lights, the vegetation is also seen. There are certain big trees like sunflower, mango trees, people trees, which grows very well in bright sunlight. We refer them as heliophytes. The plants which grow in bright sunlight, which needs bright sunlight, or where the intensity of light is very high. Intensity is very high. Such plants, we refer them as heliophytes. And there are certain plants which are referred as shade-loving plants, which grow very well in the shades. We refer them as sciophytes. shade-loving plants. They grow in very low intensity of light. They grow in very low intensity of light. Such types of plants we refer them as sciophytes. So heliophytes are the plants which grow very well if there is bright sunlight. There are some plants which are shade-loving plants. We refer them as sciophytes. Shade-loving plants, we refer them as sciophytes. Example, you find them in your gardens, inside the homes, which survive, which grows even though when there is small amount of intensity of light is there. So we refer them as sciophytes. Is it clear? Now, next is something called as the aspect of geography part. Yes, tea plant is something which requires more amount of the temperature there. Tea is heliophyte. Tea plants, coffee plants, they are heliophytes. They need more amount of temperature, right? Now, next we move on to something called as the geography part. I'll just explain this, then we can have a break of 10 minutes. 3 minutes, I'll explain this, then we can have a break, right? Now, we know that Earth, which is tilted, and also it is revolving. Earth is tilted and revolving. Now, as the Earth is tilted and revolving, this makes an impact on the apparent shifting of the sun. So this has something called as apparent shifting of sun. Shifting of sun. And technically we say this tiltation and revolution is responsible of shifting of the subsolar point north and south. It is responsible for shifting of subsolar point towards north and south. Subsolar point means at any point where the incidence of rays, sun rays are vertical, we refer that as subsolar point. So this is your geography term. Always remember subsolar point at any incidences. Wherever the sun's rays are vertically falling on the Earth's surface, we refer that as subsolar point. Now take an example. On March 21st and September 21st, the subsolar point will be on equator. So hence we refer that as equinox. Right. So on March 21 and September 21, we refer that as equinox, where the subsolar point is exactly on the equator. Now, if we take the June 21st, on June 21st, we find the subsolar point is on Tropic of Cancer. So we say the Tropic of Cancer is having the subsolar point, apparent shifting. Then if we take December 21, in the month of December 21, we say the subsolar point is on Tropic of Capricorn. So sometimes they may ask a question, subsolar point. So subsolar point is a point where the sun's radiations fall exactly vertical on the Earth's surface. We refer them as subsolar point. So hence, you should remember, the Earth's tiltation and revolution is responsible for shifting of subsolar point to the north and south. Now, when the apparent shifting of the sun, when the apparent shifting of the subsolar point is there, so it means that temperature also varies. So hence it will have an impact in the variation of temperature. So variation of temperature will be there. If you see the month of June, if you see the month of July, the northern hemisphere will be having more temperature than the south. The same area will be having more temperature in the month of June, July. But in the month of December, the same area will be having less temperature because of tiltation and revolution. We refer that as season perspectives. In the same way, when you take the month of December, in the month of December, the southern hemisphere will be having more temperature than that of the northern hemisphere. So due to the tiltation and revolution, we find variation of temperatures are there. The same area will be having extreme high temperature and the same area will be having extreme low temperature. Take an example of Delhi. So in the month of March or in the month of April, Delhi will experience heat waves. But again, in the cold seasons, Delhi will experience cold waves also. It is due to apparent shifting of the sun. The same geographical area experiences heat waves, and the same geographical area experiences cold waves. Classical example is Delhi or any part. It is all due to shifting. Plus, we all know that temperature is inversely proportional to pressure. As the temperature is more, the pressure decreases. This is in climatology. This is in climatology. If the temperature decreases, then the pressure increases. Why? Because volume is not constant. Volume is not constant here. So hence, inverse relationship is there between temperature and pressure. And this creates something called as temperature gradient or pressure gradient. And this is responsible for development of the winds. Development of the winds. And these winds, they carry moisture. They carry moisture. And these moisture, they can be onshore or offshore. These winds which carry moisture, which can be onshore or offshore. So hence, they define the precipitation. Precipitation. Perfect. They define the precipitation. So hence, the tiltation, then revolution is responsible for very important aspect, variation of temperature and variation of precipitation. So that's why if you see the monsoon rains in India, June, July, August, and September, periodic. October, November, northeast winds. Where in the southwest monsoon, we find they are onshore winds, which brings more moisture towards India. But the moment when you say northeast, when you say the retreating monsoon, so a part of the land in India, they receive the offshore trade winds, which has less moisture, except Tamil Nadu. Except Tamil Nadu. So hence we find this defines the precipitation patterns also. So hence we say that due to the tiltation and revolution, we find there is a variation of temperature, variation of precipitation, or variation of water availability. Water availability, which plays an important role in defining the flora and fauna. We can have a break and then we can start the class exactly at 7:05. Is it okay? 7:05. We'll start the class at 7:05. Done. So we'll start the class at 7:05. Okay. So we'll start at 7:10. Okay, welcome back. So hope I'm audible as well as visible to you all. Done. So keeping these things in the mind, the tiltation and revolution, we find the factors, abatic factor, temperature, and the vegetation. Now, if you see the Earth at the equator, there will always be a high temperature throughout the year, throughout the year, and the vegetation there is referred as megatherms. High temperature throughout the year. We refer that as megatherms. Evergreen type of vegetation. Evergreen type of vegetation. Then, due to apparent shifting of the sun near the subtropical areas, or say near the tropical areas, that is Tropic of Cancer and Tropic of Capricorn, sometimes you will find summer season and sometimes you will find winter season. So alternate high and low temperatures are there, which are near the tropics and subtropical areas. Near the tropics and subtropical areas. And that vegetation is referred as mesotherms. We refer them as mesotherms. Example, deciduous types of trees. Example, deciduous types of trees. And deciduous trees means they shed their leaves during the summer season and during the winter season. So alternate high and low temperature. So we have mesotherms at equator. Then the areas where the temperature is less, say near the Arctic or subarctic region. So we refer them as microtherms, low temperature regions. That is the regions between around 40 to 50 or 60 degree latitudes. We refer them as microtherms. And in the microtherms, the dominant types of vegetations are coniferous types of vegetations. Coniferous type of vegetation. Or we refer that as taiga. We refer that as taiga. And then at the poles, say Arctic region, or at higher altitude where the temperature is very, very less, So there we have hekistotherms, very cold temperatures are there. Hekistotherms, where we are having the vegetations like mosses, lichens, etc. Right, say tundra, you can say tundra vegetation. Tundra vegetation. So please remember these things. So when you make a reference of that, at the equators, you will have megatherms. And then near the tropics, you will be having mesotherms. Near the tropics or subtropical areas. Then beyond that, we are having microtherms. And then at the poles and at higher altitudes like Himalayas, at the poles or higher altitudes, we are having hekistotherms. So remember the names. They can be useful in the context of your prelims. High temperature throughout the year. Alternative high and low temperatures. Right. Then microtherms, where the low temperature is persisting, coniferous or taiga. And hekistotherms, very low temperature like tundras. Then second is water perspectives. There are certain areas where we find the temperature is ideal and heavy rainfall throughout the year. And any areas where we find heavy rainfall throughout the year, there we are having evergreen forests. Heavy rain throughout the year, that is near the equator. This is one classical example. Then heavy rain during the winter season and low during the summer season. That is where we find variations are there. And such areas, heavy rainfall during the winter season and low rainfall during the summer season. It is a unique type of area which is referred as a Mediterranean climate. Mediterranean climate. Right. And we'll see that when I take biomes, I'll explain that. Mediterranean climate. And here we find the vegetations which are referred as sclerophyllous. 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 So sclerophyllous means they are short trees and fleshy leaves. Fleshy leaves. We refer them as sclerophyllous, Mediterranean climate. Then heavy rainfall during the summer season and low rainfall during the winter season. And these are the areas which are dominated by grasslands. Dominated by grasslands. Grasslands. And then the areas where we find less rainfall, scanty rainfalls, like deserts. Deserts. And here we find the vegetations which are referred as xerophytes, water tolerant, high temperature tolerance. So we refer them as xerophytes. Xerophytes. And if you see the xerophytes, they are having fleshy stems where they store the water, and they are having the thorns which protects them. Thorns which protect them so that any plant eating animal will not eat them. So this is what we refer them as adaptation. Adaptation. So hence heavy rainfall throughout the year, the adaptation is evergreen. Mediterranean climatic condition, the adaptation is sclerophyllous. Short trees, fleshy leaves. And in the desert areas, xerophytes, and the adaptation is fleshy stems and their thorns which protect them from the herbivore animals. And the stomata is very sunken. Right. So this is some rough idea. This is some rough idea about the distribution of flora and fauna based on water perspectives. Then the next one is edaphic factors, which is associated with the soil. All the factors associated with the soil, we refer them as edaphic factors. Soil is very important because soil provides two things for the growth of vegetation. One is it provides nutrients, and second, the soil which holds the moisture, supplies the moisture or water to the crops or the plants. Soil is very important. It provides nutrients and it also provides moisture or the water to the soils. Plus, the soil provides physical supports to the agricultural crops as well as plants. It provides physical support. So hence soil plays an important role in defining the type of vegetation. Plus, if you see the nature of the soil arrangement, we refer that as topography. Nature of the soil arrangement. If any area is plain topography, then it will have thick deposit of soil. And this obviously will support more vegetation. It will support growth of vegetation. Right. And any areas where the soil is in slopes, the soil area where we are having slopes. And in the slopes, generally we find thin soils are there. And whenever thin soils are there, then we say it is limited vegetation. right? So this is one aspect of the soil. The next aspect is its pH values, that is logarithmic hydrogen part, pH value, right? So based on the pH values, there are certain soils which are ideal for the cultivation of agricultural crops. Take an example. For agricultural crops, the ideal pH value is between 7 to 8. For agricultural value, it is 7 to 8, which is ideal one. But there are certain plants which grow very well in less pH values. There are certain crops which grow in very low pH values, that is in acidic medium. And these plants, we refer them as oxylophytes. Oxylophytes, which grows in very low temperature, acidic plant, in low temperature, like near the Arctic. Example of oxylophytes is Arctic grass, or mosses. Arctic grass or mosses. And there are certain plants which grow very well if the salinity is more. They are called as salt tolerant. And the best example of these are the mangroves. And we refer them as the halophytes. So we have salt tolerant, we have acid tolerant, and we also have the crops which can be in between 7 to 8, the ideal pH value for agricultural crops. Neutral in pH means salty. No, we don't say that. Exactly, we can't say, because there are certain areas where 7 is referred as neutral, but sometimes when we say, take an example of acid rain, we don't call acid rain when its pH value is 7. We call it as acid rain only when the pH value is less than 5.6. It depends on certain parameters. So generally we say 7 is neutral, and less than that is acidic, and more than that is the what we refer them as the saline part. So these are adaptive factors. It defines these three things. Plus topography. Hence, northern plains is rich with biodiversities. Gentle slopes will be having more if it is gentle slopes. Then ideally it will be having more vegetation than steep slopes. More vegetation than steep slopes. Yes, you have to remember them. So these scientific names, sometimes in prelims they may ask. In the prelims they may ask. Right. Now next we move on to biotic factors. Biotic factors. In that, the first one is the producers. Autotrophs, which produces their own food. Or produce their own energy. So in the producers, we define entire group into autotrophs. And this autotrophs has two subdivisions. Autotrophs has two subdivisions. The one where they produce their food in the presence of sunlight, we refer them as photoautotrophs. Where they produce their food in presence of sunlight. In presence of sunlight, we refer them as photoautotrophs. And there are certain organisms, say insects, where they produces their energy or produces their food in the absence of sunlight, which produces their food or energy in the absence of sunlight. We refer them as chemoautotrophs, and generally they produce by a chemical reaction. But if you see photoautotrophs, all the green plants are referred as photoautotrophs. Green plants. are referred as phototrophs because they use the sunlight. In the presence of sunlight, carbon dioxide which is used by them, and they produce their food in the form of carbohydrates, plus oxygen is released. Carbohydrate and oxygen is released, and we refer this process as photosynthesis. We refer this as photosynthesis, right? So which absorbs the sunlight. In the presence of sunlight, they take the carbon dioxide, and then due to the reactions, they produce the carbohydrate which is stored them in the form of food, and then oxygen is released. We refer that as photosynthesis. But not all the sunlight is used for photosynthesis. If you see the sunlight and its wavelength, among all the sunlight wavelength, the wavelength between 400 to 700 nanometers, the sun's wavelength in between 400 to 700 nanometers, we refer that as photosynthetic active radiation. I'm repeating, 400 to 700 nanometers. 400 to 700 nanometers. So this wavelength is ideal for photosynthesis. Is it clear? So in between 400 to 700. Now this photosynthesis, or we say photosynthetic active radiation, is it always permanent? PAR, can you answer this? Is it permanent? No, it always varies from time to time, place to place. So this PAR, it varies with time, it varies with latitudes. Right, this is how you have to make reference of your studies. So photosynthetic active radiations, it always varies with the apparent shifting of the sun, season wise, and it also varies day and night. So in the daytime, we find more amount of PAR is there. So where the photosynthesis is dominant, but in the night, we don't have PAR. So hence, it varies from time to time, latitude to latitude, days to days. So hence, when you talk about growing of any agricultural crops, PAR is very important one. So when you are growing any crops, they always check what is the value of PAR which they are getting for particular type of the crops. Is it clear? So we refer them as producers, and in the producers, they are referred as photoautotrophs. So all the autotrophs can be defined into two categories. One is photoautotrophs. So whatever I have discussed is photoautotrophs. Then we move on to chemoautotrophs. So what are chemoautotrophs? Chemoautotrophs, these are the one which produces their energy in the absence of sunlight. Where the sunlight cannot reach. And where do you find them? You can find them examples which are in the soils, embedded in the soils, like the nitrogen fixing bacteria. Like we are having nitrobacter, which oxidizes nitrite to nitrate, and then nitrosomonas. So these are nitrogen fixing bacteria which are used in agriculture. And we can find them even in the volcanic vents. And we can find them in the deep oceans. We refer them as hydrothermal vents. Deep oceans, where the sunlight will not reach, we refer them as hydrothermal vents. So we refer them as the chemoautotrophs, which produces the energy by chemical reaction. So it means they do not require any sunlight. Yes, Ankush, yes, PR is an active determinant of vegetation. Yes, because based on that only the crops are grown, right? So whenever we say the Kharif crops, Rabi crops, they change because they need a particular type of water and particular type of sunlight. Yes, it is an active part. Perfect. So this is about the photoautotrophs and chemoautotrophs. Right. Then consumers, which depend on the producers, and we refer them as heterotrophs. Heterotrophs, which depends on the producers. They depends on the producers. That is autotroph. So here we are having the varieties. Plant eating, we refer them as herbivores. Plant eating. Then carnivorous, flesh eating. Flesh eating. Then omnivorous, both. Both are there. Then here you should remember, along with these, we also have something called as scavengers like vultures, rats, etc. We refer them as detrivores. Right? Example, vulture, rats, many insects, etc. We refer them as detrivores or scavengers. Detrivores or scavengers, right? And what they do, they feed on dead, undecomposed organic matter. They feed on dead, undecomposed, undecomposed organic matter. It can be rotten meat or it can be any plant. They feed on undecomposed organic matter. We refer them as detrivores or scavengers. In fact, in fact, these are referred as subsets of decomposers. So they are referred as subset of decomposers. Subset of decomposers. So remember here, herbivore, carnivore, omnivores, and detrivores, they are the part of consumers. They are the part of consumers. The next is the decomposers. Now, the decomposers, they can be fungi, bacteria, insects, etc. So they can be microscopic, or you can see them through the naked eyes, like mushrooms. Mushrooms, which are fungi. Now, what is the major role of decomposers? What is the major role of decomposers? Now, the decomposers, they play a very important role. They convert the organic stuff. These decomposers, like microscopic bacteria and mushrooms, etc., they act on the organic stuff, that is dead organic stuff, and they convert the dead organic. They convert this dead organic into inorganic substances, into inorganic. That is very, very important role of decomposers. So without the decomposers, organic cannot be converted into inorganic stuffs. Like any dead plant is there, when it is acted upon by decomposers, then it is converted into inorganic substances like calcium, carbon, etc. Calcium, carbon, etc. Right? So they play a very important role, vital role in converting the organic stuff into inorganic part. So that is the role of decomposers. And these are the one, these organic, when they convert into inorganic, they are recycled in ecosystem. They are recycled in ecosystem. So decomposers play a very important role in recycling these, and we refer them as nutrients. Recycling of nutrients. Right. So these inorganic substances are nothing but the same. We refer them as nutrients or matter. nutrient or matter, right? uh, Now when we talk about the last one, so last one in the sense decomposer. So when we talk about the detrivores, so detrivores are the organisms which are bigger one. Take vulture, crab, rat, etc., which feed on undecomposed dead plant and animals. We refer them as scavengers. They are the subsets of decomposers. Is it clear? Virus feed on alive human organs. Sometimes when we say they are called as pathogens, they are called as pathogens. When we talk about that, we have many types of viruses are there. HIV virus, right? They are pathogens, disease spreading viruses are there. In SNT, you will come across them in detail, right? So decomposers, they play a vital role. Now, this is a difference between decomposers and detrivores. Please read them carefully. So, the moment when we say detrivores, so detrivores, they eat the remaining dead plants and animals like crabs, earthworms, etc. And decomposers, they break down the organic matter and feed on them. Example, bacteria and fungi. So, bacteria and fungi are decomposers. These are decomposers. Please read them carefully. And detrivores, they break the large organic matter into smaller fragments. So we refer them as degradation. Degradation. And here they decompose that. This is called as degradation. And this is called as decomposition, changing the complex characteristics. Decomposer. Decomposition. And the major thing is these bacteria, they convert the organic stuff into inorganic. Please keep this in the mind. They convert the organic into inorganic substance. We refer them as nutrients. And these are recycled. These are the one which are recycled. See, when we say, when we define them, certain insects are there. Certain insects are there which break down. We refer them as detrivores. We refer them as detrivores, right? So don't get much confused. Don't get much confused. Some insects are there which can be decomposers. So ideally, we define them as detrivores and decomposer. As I told, detrivore is a subset of decomposer. As I told, detrivore is a subset of decomposer. Is that clear? Okay. Now next, functions of ecosystem. So as I told in the initial or in the beginning that there are two important things which are exchanged in the ecosystem. One is matter and second one is energy. So always there is an exchange of energy and the exchange of matter in the ecosystem. Matter is also referred as nutrients. Nutrients. Now we'll try to understand how the exchange of matter is done. How the exchange of matter is done in the ecosystem. Matter means, keep this in the mind, nutrients. Nutrients. So nutrients means carbon or calcium, magnesium, etc. Nutrients means magnesium, carbon, calcium, etc. So we refer them as nutrients. How they are recycled or how they are in the ecosystem. Now very simple. This is a land area, a lithosphere. And in the lithosphere, we find trees are there, grasses are there, and they have the roots. They have the roots. And always remember, the nutrients enters into the plant's roots. Nutrients enters into the plant's roots. Maybe magnesium, calcium, etc., which enters into the plant's roots. And then it is seen in the different leaves and different parts. So the nutrients enters through the roots and then it will spread into all the vegetation, that is trees or grasses, where they perform photosynthesis. It is used by them. After that, this is eaten by, say, rabbit. This tree or grass is eaten by a rabbit. I'm giving an example. It means that the nutrients which are there in the trees will be transferred to the rabbit. So the nutrients will be transferred to the rabbits. Rabbit will not have their own. So they are transferred because rabbit is a consumer. It is not a producer. It is consumer. And this rabbit is again eaten up by, say, a tiger. A tiger. So the nutrients which are carried by the plants to the rabbits are again transferred to the tiger. So the nutrients are transferred to the tiger here. So this is how the nutrients are transferred to the tiger. Then when the tiger dies, or when the rabbit die, when the tiger die, when the rabbit die, or again when the plant also die, all three are living. When they die, when all the three die, they are acted upon by decomposers. That is bacteria. Now what is the role of bacteria? They convert the organic into inorganic substance. They convert the organic stuff into inorganic. And this inorganic, which is produced by them, which is developed by them, which is end product of their reactions, they are nothing but what we refer them as the minerals, nutrients, calcium, magnesium, etc. And these inorganic substances in the form of calcium, magnesium, etc., they enter the soil or the rocks. They enter the soil or the rocks. After that, this is again entering into the green plants. So these nutrients enter into the green plants. So a systematic cycle is being formed. So bacteria, they convert the organic stuff into nutrients, and the nutrients are taken by the green plants, and then again by rabbits, tiger, and this. So this is a continuous cyclic process. It is not unidirectional. It is recycled. So the nutrients are recycled in the ecosystem. And what is the dominant role of bacteria? They convert the organic into inorganic substance. If you remove the bacteria, then it becomes very difficult for the recycling of the nutrients. So hence, the bacteria or decomposers plays an important role in recycling of the matter, recycling of the nutrients. Right? They may be eaten by the scavengers. So we say scavengers means they can reduce them. As I told you again and again, that scavengers they are also the subsets of decomposers. So scavengers will eat them, and then again left out portion is acted by the bacteria. Perfect. So both are the same. So they are recycled in the ecosystem. So hence, if you study the geographical part, we come across many type of cycles there. We refer them as biogeochemical cycles. Chemical cycles. Now, can you give any example of biogeochemical cycle? Any one cycle of biogeochemical cycle, which makes the movement of the nutrients from the soil and again coming back. Carbon cycle, oxygen cycle, water cycle, right? So phosphorus cycle, etc. Carbon cycle, phosphorus cycle, etc. So nitrogen cycle, etc. So these are referred as biogeochemical cycles. And hence, the bottom line is the matters in the ecosystems are cyclic. The matters exchange in the ecosystem in the form of cyclic. Please fix this in the mind. So hence, the matters are always cyclic, and the dominant role played is by the bacteria. If you remove the bacteria, then there is a possibility of the cyclic pattern can be disturbed. Is it clear? Okay, so this is about the first aspect. We refer that as cyclic. And what are biogeochemical cycles? So biogeochemical cyclones can be of any type. Like we have producers like green plants and all, which they use the energy and produces the energy. And these are eaten up by the consumers, and the nutrients are transferred to that. Nutrients are transferred to that. Right. After that, when the consumers die, they are acted upon by decomposers. When the producers die, they are acted upon by decomposers. And these decomposers like bacteria, they convert the organic stuff into inorganic nutrient. And these inorganic enters into the producers. Now, what are producers? Producers are green plants here. Green plants. Right. So this is what we refer them as many types of cycles: carbon cycle, nitrogen cycle, magnesium cycle, phosphorus cycle, which are referred as biogeochemical cycles. So hence we say the matter is cyclic in the ecosystem. Okay, we'll discuss that, why they are not highest trophic level rather than apex predators. So that is the major problem. So we'll take up slowly one by one. So when I take that, I'll explain that part. Right. So biogeochemical cycle is a process where we find that the nutrients are entering into the ecosystem through the roots of the plants, and then these nutrients are consumed by the producers like human beings, animals, etc. And after consuming that, we generate the wastes. Like when we consume them, we generate the wastes either in the form of greenhouse gases or in the form of many such, which again are entered either to the atmosphere, or when we die, when the plants die, they are again acted upon by the bacteria, and then they are recycled. Right. So this is what we refer them as the biogeochemical cycles. Right. So it cannot be destroyed. It is always recycled. It is always recycled. Now the second aspect of this is the energy flow. Energy flow. Now focus on this part. Energy flow. Now the moment when you say energy flow, energy is very important one. It is essential to maintain the life activities, and this energy, it enters into the ecosystem through photosynthesis. It enters through the photosynthesis. Right. Through the photosynthesis, and then it is transferred. To higher level. Then it is transferred to the higher level. Now this transfer of the energy, this transfer of energy to the higher level is explained by the two laws of thermodynamics. Is explained by the two laws of thermodynamics. We'll see what the law says. In a simplified way. But before that, what is the role of this energy? This energy, which is produced by the green plants by the process of photosynthesis, when it is transferred from one level to another level, it is important for maintaining the stability of the ecosystem. So it maintains structural stability of ecosystem. It maintains the structural stability. Right. Now, how this energy is transferred, which is responsible for maintaining structural stability. Structural stability means their growth, reproduction, etc. Example: growth, reproduction, etc. Right. Now, how this law explains and what it says. Now, it's very simple to remember. Green plants, they produces the energy, and we refer them as producers. So these are producers, which produces the energy. by the process called as photosynthesis. And when this is eaten by rabbit, I'm giving an example, rabbit or goat or cow, then we refer this as consumer or primary consumer. Primary consumer. Right. Rabbit. The energy is transferred from the green plants to the rabbit. That is primary consumer. Then this rabbit is eaten by, say, dog. It is eaten by a dog. And we refer that as secondary consumer. Secondary consumer. And this dog is eaten by, say, tiger. That is tertiary consumer. Tertiary consumer. So in all the cases, we find energy is transferred from one level to another level. So the energy is transferred from one level to another level. One level to another level. That is from producer to primary consumer to the secondary consumer to the tertiary consumers. So the energy is transferred here. Energy is transferred here. And this is a process of the rabbit is eating the green plant, or this rabbit is eaten by the dog, or this rabbit is eaten by dog. So this process of eating and being eaten up, this process of eating or being eaten up, this process of eating or being eaten up, which makes the flow of energy. Which makes the flow of energy is referred as food chain. Is referred as food chain. Very simple. So food chain defines the flow of energy from producer to primary consumer to secondary consumer to the tertiary consumer. Now this is sequential. This is sequential. It is sequential. Right. Now there is no possibility that the rabbit will eat the dog. There is no possibility that the dog will eat the tiger. So it is unidirectional. Sequential and unidirectional. Unidirectional, right? So hence energy flow is unidirectional, moves from one level to next level. And here you should remember, every level is represented by a rectangular box called as tropics. Every level is represented by a rectangular box called as tropics. So tropics of primary consumers, tropics of secondary consumers, tropics of tertiary consumers. So the moment when you say tropics, it means that they represents the hierarchy or level of their organization. Level of their organization. That whether it is a primary consumer or whether it is a secondary consumer. So this is called as the first law, where the energy transfers from one to second, and it is always carry forwarded. It is always carry forwarded, right? It is rectangular, not triangular, rectangular boxes. So tropics are always represented as rectangular boxes, generally in the rectangular box. Is it clear? So what are the two laws of thermodynamics? The first law says that energy can neither be created nor be destroyed. It can always be transferred as well as transformed. So here, if you see the graph, the primary producers, they produce the energy in the form of photosynthesis. photosynthesis. After that, it is transferred to primary consumer, then secondary consumer, then to the tertiary consumers. Then to the tertiary consumers. So this is called as the first law of thermodynamics. First law of thermodynamics. Is it clear? Now, the second law is a bit complex. It says that there is always a loss of energy during the transformation. It's complex but very easy. Now, whenever when you talk about the energy, so now whenever when you talk about the energy, understand this. Rabbit has taken the energy from the producer. Now, rabbit which has taken the energy, will it transfer entire energy to the dog? Will it transfer entire energy to the dog? Entire energy of the rabbit, will it transfer to the dog? Or entire energy of the dog will be transferred to the tiger? No. Why? Because these organisms use their energy for their survival. So these organisms, they use their energy for their reproduction, metabolic activities, right? And this is called as the energy lost when it is transferred. So these organisms, these organisms, they always use the energy for their reproduction, metabolic activities, or growth, etc. So they use the energy, reproduction, metabolic activities, growth, etc. And this is the energy. This is the energy which is used by the organisms. This is the energy which is used by the organisms. So can we say this energy which is used by organism as the energy lost in the food chain? So this is the energy which is says as the energy lost in the food chain when it is transferred from one level to second level, right? So this is what we refer that as energy loss. And energy loss is seen at every stage, because producers will have their own path. Primary producer, primary consumers, they will be having their own approach in that, right? So this is what you should remember in the context of first law as well as the second law of thermodynamics. In the second law, there is no 100% of transfer of energy. So there is a loss of energy, and this loss of energy is the energy which is used by the organism for their metabolic activities, reproduction, and for their growth. Now the question is, what amount of energy is transferred? Now the question is, what amount of energy is transferred? Now, this is what we have to understand. So these are the two laws. Energy can neither be created nor be transferred. There is always loss of energy during the transformation of this, right? Now, when we talk about that, see, first you understand the PPTs, first you understand the class, then you can decide which book you want to read. Whether you are reading Shankar IS Academy or any book, it does not have any much impact. See, that all the books are very good. I'm not telling that that book is worst or something. First you understand the process. So once you understand the process, once you go with the PPTs, then based on the PPTs, you can select the topic and read that. If you take Shankar IS Academy book, it is very bulky. Is it possible for you to revise all the topics at one time? It's become difficult. So understand the class. So when you're attending the class, understand the topics and makes notes based on the PPTs and refer either Shankar IS book or any book. From there, you can fill up the skeletons. Understand the flow, the terminologies, and then you can take any book. I'm not telling that you refer only one book. From any book, any good book, you can take the references. Right. So no problem. Any book you can read. You can take Shankar IS book. You can take any book. No problem. They are having. But whenever when you are attending that, that is sufficient. Along with the PPTs, if you take some areas wherever the dry areas where you are missing, you can take it from any book and fill that. That is more than sufficient. That is more than sufficient. Is it clear? Now, the first and second law. Energy is always lost when it is transferred in the food chain. Now, the definition is the flow of energy or the sequence of eating and being eaten up. We refer that as food chain. And each stage is represented by separate tropics. These are called as tropics. Rectangular box, we refer them as tropics. And these provide structural stability to the ecosystem. And every tropic defines the feeding pattern of that, whether they are herbivore, whether they are omnivore, or whether they are carnivore. So they define their feeding habits, whether they are herbivore or whether they are carnivore or whether they are omnivores. Whether they are omnivores. So this is what the terms you should remember, right? Structural stability. Now, the question is that what amount of energy is transferred? What amount of energy is transferred? The second law says that always there is a loss. Now we have to calculate the energy which is transferred. Now here you should be very good enough in understanding certain points. The total energy which is produced by the green plants in the first stage, we refer that as gross primary production. So this energy which is produced by the green plants in the initial stage is referred as gross primary production. Gross primary production in the beginning stage. And the energy which is lost at each stage, lost means the organisms which are used there for their growth, is referred as R. R. So R is something which is not transferred. R is which is lost. So GPP minus R is the energy which is transferred. GPP minus R. So remember this. GPP minus R is the energy which is transferred. And this energy which is transferred, we refer that as net primary production. Net primary production, NPP, which is always transferred. So remember the technical terms. NPP, which is always transferred. Right. So remember, the first energy which is produced here is referred as gross primary production. The total energy. Total energy is gross primary production. And the energy lost at every stage is referred as R. Every stage there will be energy which is lost. R is the energy which is lost. Lost means they are used there for growth. Lost means this energy they are used for their reproduction. They are used it for their metabolic activities. And they are used it for their growth. Right. So keeping this in the mind, gross primary production minus R is something called as net primary production. And net primary production is the energy which is transferred. Energy transferred in the food chain. Energy transferred in the food chain. We refer that as NPP. So every tropic will have their own net primary production. Every tropic will have their own net primary production. And every tropic will always lose the energy, which is called as R. It is lost. So if the total amount of energy here, so they use the energy for their productivity and the remaining energy is transferred. So net primary production is transferred to the primary consumers. So they will use that, and out of that R is lost and the remaining is transferred to the next level. So NPP from here is reaching to the next level. Now again they will use for their metabolic activities and the remaining energy is transferred. So always remember it is the NPP which is always transferred. Always transferred. Right. Now energy at each tropics. the energy at each tropic is referred as standing crop. This is the technical term you should remember. Standing crop, or it is referred as amount of living material. Amount of living material. Standing crop or amount of living material. Standing crop or amount of living material. Now when we compare the standing crop at each level, when you compare the standing crop at each level, we find that not all the energy is transferred. Only 10% of energy is transferred. 10% of energy is transferred. And this 10% of energy which is transferred, is referred as ecological efficiency. Is called as ecological efficiency, or it is also called as 10% rule. 10% at each level. Now, simple example. Understand this. So if the total amount of energy which is produced in the producer is say 10,000 joules. The total amount of energy which is produced in the producers is 10,000 joules. So what is 10% of 10,000? What is 10% of 10,000? Right. So the 10% will move on to the primary consumer. So this will be 1,000 joules. Now what is the 10% of 1,000 joule? 10% of 1,000 joule, it is 100. So 100 units will reach to the secondary consumer. Then again, what is the 10% of that? 10% of that is 10. So 10% or 10 joule will reach to this, to the tertiary consumers. So this is called as the 10% rule. Right. So average, when they calculated, they found that only 10% is transferred because 90% of the energy is used for the reproduction, metabolic activities and all. So hence we always find only small amount of energy is transferred. Right. Comparison between the different standing crops at each level. So only 10% of energy. So hence we don't have big consumers to eat up. So hence most of the food chains are only up to 3 levels or 4 levels. So as only 10% of energy is transferred, if you see many food chains, most of the food chains are only up to 3 level or 4 level. We don't have big consumers to eat them. So hence we find most of the food chains, they have 3 levels or at the max 4 levels, because only 10% of energy is transferred from one level to next level. So hence most of the food chains, they are having 3 or 4 level: primary, secondary, tertiary. We don't have big consumers to eat them because energy itself is very, very limited here. Right. And the terms and their full forms are thus: GPP, gross primary production; R is the energy lost; net primary production, which is transferred; amount of living material or standing crop, energy in each tropic level; ecological efficiency, that is 10%, or Lindemann's law. Is that clear? So this is what you should remember when you talk about energy, right, in the ecosystem. So always remember that matter in the ecosystem is cyclic, whereas energy in the ecosystem is non-cyclic and unidirectional. unidirectional. Standing crop means it is the energy which is stored in that part. Standing crop means it is a technical term. You don't have to go in detail. Crop does not mean that the crops what we grow. Standing crop or amount of living material means the energy which is there. Energy at each level. Standing crop is energy at each level. Is that clear? Why? Please reframe your question. So this is what we say. If we are having a total 10,000 joules of energy is produced, 10% will move on to the next. 90% is used by the green plants for their survival. And then again, it is moving from one to the next level. So we refer them as a very important concept called as Lindemann's law. So energy is non-cyclic and unidirectional. Is that clear? Now, keeping all these things in the mind, ecosystem definition can be something like this. An ecosystem is a functional unit composed of biotic and abiotic components where they integrate with their physical environment, and there is always a flow of energy and flow of nutrients. So it is a flexible, open system, functional unit of biosphere. So this completes the definition of ecosystem along with their conceptual part. Now don't make in-depth analysis. This is more than sufficient in the context of your understanding. Yes, rather than demand more energy. So that's why dinosaurs are missing, right? So they need huge amount of food. So from where you can provide them food? So we find the highest predators are at the max, the tigers and the lions. The bigger than that are missing. Why? Because they do not have the sufficient energy to be supplied. Okay. Now types of food chains. Types of food chain. So generally we define them as two types of food chain. One is the food chain. If it starts from the green plants, we refer them as grazing food chain. If it starts from the green plants, we refer them as the grazing food chain. Producer by photosynthesis, then primary consumer, secondary consumer, and tertiary consumer. If the food chain starts from dead plants, if it starts from dead plants or dead animal, rotten flesh or rotten leaves are there. So from that, if it is entering into the food chain, woodlouse and blackbird, we refer that as detrital food chain. So one grazing food chain, herbivores, and then moving. Then if it starts from detritivores like woodlouse, etc., then we refer them as detrital food chain. So two types of the food chains are there: grazing food chain and detrital food chain. Simple. Photosynthesis, green plants, herbivores, and they transfer that. Detritals, detrius, detrivores. So we refer them as that. And generally, detrius food chain is smaller. This is generally small and the size. And these are usually very large. Grazing food chains are usually very large. So remember, two types of food chains are there: grazing food chains and detrital food chains. Don't make in-depth analysis. Just remember the names: grazing and detrital. Both types are there, right? Now, next we move on to understand a very important concept called as food chain and food webs. Now, what is food chain and what is food web? Now, the moment when we say food chain, right? So it is linear. It means it is in the straight line, and it is very simple. It is very simple. Now, take an example. This is an ecosystem A. This is an ecosystem A, which is having a food chain. Ecosystem A, where it is having a food chain. So producer is there, primary consumer, secondary consumers are there. It is a food chain. Now, if the number of rabbits decreases, If the number of rabbits decreases, it means maybe due to disease and maybe due to something. What will happen to the number of hawks? What will happen to the number of hawks if the number of rabbits decreases? If the number of rabbits decreases, what will happen to the number of hawks? The number of hawks will also decrease. So number of hawks will decrease. Why? Because there is no alternate arrangement for the hawks to eat. There is no alternate arrangement for the hawks to eat. So such types of food chains which are linear and simple, we refer them as food chains. Right. Now, another ecosystem is there, which is referred as ecosystem B. So in this ecosystem B, we find many food chains exist. So this is one food chain which consists of the normal grass, rabbits, and the hawks. This is one food chain. Then second food chains like grasshopper, lizard, and the hawk. Second food chain. Then also it consists of grass, mouse, and the hawks. Third food chain. Right. Or sometimes you may say mouse, snake, and so forth. So here we find the food chain has become complex. Right. So now it is not linear, it is very complex. So hence, if the number of rabbits decreases here, what will happen to the number of hawks? Will it decrease or will it remain same? If the number of rabbits decreases in the ecosystem B, it remains the same. Why? Because hawk has alternate arrangement. The number of hawks will not decrease. Why? Because it is having an alternate arrangement. Alternate arrangements are there. And such alternate arrangements, where the food chain become complex, we refer that as food web. Which provides alternate arrangements for the possible maintenance of stability of ecosystem. So a food chain will be having food webs will be having many food chains. Many food chains. Now here easily you can identify that in this ecosystem B, which represents the food web, has 4 food chains. This is a food web with 4 food chains. So hence, these are the terms which you should remember: food chain and food webs. Is that clear? Simple, complex. Now, 2 important terms: bioaccumulation and biomagnification. Bioaccumulation and biomagnification is a term associated when a pollution or pollutant enters into the food chain. When a pollutant enters into the food chain. Now what will happen? So when the pollutant enters into the food chain, if its quantity increases, then that pollutant will become threat to the organisms. This pollutant, it can become threat to the organisms, or it can lead to death of organisms. Right. So pollutants, when they enter into the food chains, they can become threat to the particular organism which have consumed them, or which can lead to the deaths. So I'm using the term, if their concentration increases, then we refer them as a pollutant. Now, very simple to remember. The water which you are drinking, Bisleri water, and the water which is taken from the normal river or normal lake. So can we say that the water which you are drinking does not have any type of the pollutants are there? Any type of objects, any type of the substances? They will be having substances, but in lesser proportion. If the proportion increases, then we refer that as a pollutant. If the concentration increases, which can become a health hazard, which can become a dangerous condition, then we refer that as a pollutant. So if it become a threat or leads to death, then we refer that as a pollutant. We refer that as a pollutant to that particular organisms. Is it clear? Now, two terms are associated with that. The first one is called as bioaccumulation. What is bioaccumulation? When the pollutant enters into the food chain, into the first organism, when the pollutant enters into the first organism, that is the producers, we refer that as bioaccumulation, entering into the first organism or entering into the organism, we refer that as accumulation. So it is accumulation of the pollutant into individual organism. It is accumulation of toxins into individual organisms over a period of a time, maybe 1 month, 2 months, 3 months, 4 months. So initially it starts accumulating 3 months, 4 months, 5 months. So its concentration increases and then it becomes a hazard, threat to that species. So we refer that as bioaccumulation. That is the toxins or the pollutants increasing in the individual organisms over a period of a time. We refer that as bioaccumulation. Now, this organism is eaten up by next hierarchy, secondary consumer, and that pollutant is transferred to the secondary consumer, and the secondary consumer is eaten by the tertiary consumer. So here we find the pollutants are transferred and we refer that as bioaccumulation. So bioaccumulation is a process where the pollutants are transferred from one level to next level, one level to next level. And when they transfer, they increase the concentration of pollutant, increasing concentration, where to the higher predators, increasing in the concentration of the pollutants in the higher predators, in the higher level, higher predators. We refer that as biomagnification, from one trophic level to second trophic level. Now, how it is possible? It can take place only if the pollutant is active for a long time. If the pollutant is active for a long time. Then second one is that if this pollutant is fat soluble, if it is fat soluble, bioaccumulation means, yes, bioaccumulation is in the single specific, we refer that as bioaccumulation. Please read this. In an organism, so we refer that as bioaccumulation. Biomagnification means when it moves down from one level to second level, we refer that as biomagnification. Right. So it is active, that is biologically active. And if it stays for a longer period of a time, then its concentration increases when it is eaten up by the next level. We refer that as. So here we are talking about pollutant, not energy. Energy is different, pollution is different. It is not the energy, it is about pollutants. So don't get confused. So here the capacities are different. So generally when we say the toxins are ingested at higher rate than they eliminate, there are organisms where elimination can be more. There are certain organisms where the elimination of the toxins in their excreta or somewhere may be very, very less. It depends on their resistance, it depends on their capacities, right? So hence we refer that as bioaccumulation and biomagnification. So don't get confused. So bioaccumulation is when the pollutants enter into the first level, and biomagnification is when the pollutants increase in the concentration into the next level. So this is a classical example of biomagnification. Insects, birds, and larger birds. In the first level, we refer that as bioaccumulation. And when they become threat, then that becomes a major cause of concern. Now, the classical example of bioaccumulation and biomagnification is, we have seen in the context of vulture. In the context of vulture. So vulture is a detrivore. Now this vulture, it is a detrivore, or we say it is a scavenger. And this vulture, it feeds on the dead plants, sorry, dead animals. It feeds on the dead animals. Now, what is this vulture episode and how it is responsible to bioaccumulation and biomagnifications? Generally, when you talk about the cattle, to relieve the cattle from the pains, painkillers are given to them. Painkillers are given to the cattle. Now, the classical example of that is diclofenac. Diclofenac. It is an anti-inflammatory drug. Diclofenac, it is an anti-inflammatory drug. A painkiller which is given to the cattle. So the cattle will consume this diclofenac. They will consume the diclofenac and they get relief from the pain, but they can't decompose the diclofenac. These cattle can't decompose. And this diclofenac will remain in their carcasses. This diclofenac will remain in their carcasses. So what is carcasses? The dead body of these cattle. The dead body of these cattle in the carcasses. Now these carcasses, when they are eaten by vulture, when they're eaten by the vulture, then this diclofenac enters into the vulture. This diclofenac, it enters into the vulture. And vulture does not have capacity to digest that. And this diclofenac created a renal disease to the vulture. Renal disease to the vulture. Renal disease means kidney failure. Kidney failure. And that was responsible for large amount of deaths of large number of deaths of these vultures because of the consumption of the diclofenac. Because of the consumption of diclofenac. And the numbers decreased so drastically in between 1990s, 1998, and even 2000s. The number drastically decreased to more than 90%. In fact, more than 95% decrease was there. Catastrophic decrease, drastic decrease in the vulture population. In the vulture population. And if you take an example of that, in the context of India, we have 9 species of vultures. 9 species of vultures are there. Out of these 9 species, these three species, that is long-billed vulture, slender-billed vulture, and oriental white-backed. So these 3 species of vultures, their numbers drastically decreased compared to the remaining 6. And hence, these 3 species are classified as critically endangered species. They're referred as critically endangered species in the context of vulture. So even today, we refer that out of 9 species of the population, 3 species in India, they're referred as critically endangered species. Critically endangered species because of diclofenac. So this is a classical example of yes, it can be. So when you talk about that, they transfer from one species to another if it is having such types of that. It is something which is transferred, bioaccumulation and biomagnification. So this is one. classical example. Now these vultures are very important because they are scavengers. If you remove the scavengers, then the dead rotten flesh will create many disease, and they can be harmful for the society. So hence these vultures are very, very important. Now that is where government decided that we need to protect and conserve the vultures, and hence the first national vulture conservation plan was introduced in the year 2006. So it means that to protect these species, and there the diclofenac drug was included in schedule H. So it means that in the context of any type of veterinary practices or veterinary drugs or medicines, the veterinary druggist can sell this diclofenac only on prescription. He can sell the diclofenac only if he is having prescription. It means this prescription will say what amount of volume has to be sold. So the first conservation plan was done in the year 2006, where they included the diclofenac as schedule H. Now this was not fruitful because there were many incidences that this diclofenac was continuously used, and apart from that many inflammatory drugs were used, but that created again a large amount of deaths. So hence the second national vulture conservation plan has been started by India from 2020 to 2025. And here the first thing is the carcasses are the major cause of transferring. So hence the burning of carcasses is taken in the first priority. Then second, plan to consider the diclofenac in schedule X. Now what does the schedule X means? Schedule X means that he has to sell it only in the prescription, plus he has to sell that only with the prescription. The druggist has to sell it only with the prescription, plus he has to keep a copy of the prescription to whom it has been sold. He has to keep the copy of prescription for at least 2 years. For at least 2 years. Is that clear? So not 9 p.m. Another 2 minutes we'll wind up. I don't take the class up to 9. Another 1 minute and just we'll wind up, because anyway you are having Saturday and Sunday. You can revise that. It will not be up to 9 p.m. Another minute or so, because I don't want to keep this for next day. So carcasses, prescription of keeping the copy, he has to maintain that for 2 years at least, to whom it has been sold. Then these vultures, they always have low fertility rates. These vultures have low fertility rates. So it means their birth rates are very, very low, right? So hence one safe zone has to be developed in each state. So that was a major step. At present, we are having 8 zones. At present, we are having 8 vulture conservation breeding zones are there. And we are making an effort to create another 8 by in another 2025. So already 8 are existing. Already 8 are existing. An effort is to increase to another 8. Increase to another 8. So these 8 breeding centers which are existing, 8 breeding centers which are existing are in Haryana, Gujarat, Hyderabad, Orissa, and these areas. Right. So hence this diclofenac drug is banned in India in the year 2013. Now, in the year 2023, 2 more drugs were banned in India for the veterinary. 2 more drugs were banned in India. So can you name them? Which are the 2 drugs which were banned by the government of India in the year 2023? The 2 drugs which were banned by the government, so that the population of these species will not be affected by them. Any idea which are the drugs which have been banned by the government? Current affairs. Current affairs in the year 2023. Yes, ketoprofen. Ketoprofen. Not ibuprofen. Ibuprofen is there. Ketoprofen is there. Then aceclofenac. These two are banned. Ketoprofen and aceclofenac is banned. Then we have one more drug which is not yet been banned. High Court has said that why you are not banned that drug. Why you are not banned that drug. Now, which is that drug which is not banned? Still not banned. Still not banned. Nimusalide. Nimuslide, sorry. Nimuslide. Yes. So this is something about what we refer them as bioaccumulation and biomagnification. A simple example is that about the vultures. So hope read them. Try to figure out the terms current affairs. So this is your current affairs as well, right? So and read them, revise them, whatever has been covered here. And Monday I'll be taking up, sorry, Tuesday I'll be taking up the remaining aspect, that is mercury contamination was seen in Japan called as Minamata disease. So Monday we'll discuss Minamata disease, and then we move on to level of organization. Then we move on to level of organization. So this is not yet banned. Nimuslide is not banned. Is that clear? So take care, enjoy the weekend, and don't get much stress. Read them as simple as possible. Don't worry about the content and all. Try to focus them, accumulate the information, accumulate them in the format, make your proper notes, keep the PPTs, read the current affairs, mix up them. Then you will find interesting in your studies. Try to put them into diagrams, flow charts. Then it becomes more interesting. Which book you are reading is not important. How best you are extracting from that book is very important. Whether you are reading from Shankarayas or anything, it is not that important. What you are extracting from that is important. It is about digestion, right? So make sure that you digest good amount of content and try to make notes whenever you complete that particular topic, right? So we'll meet up we'll meet up again on Tuesday. So till then, take care, enjoy weekends, and happy Holi in advance for the Monday. So enjoy the Holi festival. You should celebrate the festival so that it can bring rejuvenation in you. So don't get 24/7 burdened with your studies. You should celebrate the festivals so that it can rejuvenate the energies, where the cultures are important, which can release the stress. So you should be a part of festivals, cultures, enjoy them. As a humans, you should be a social animal, right? So you should be involved in all those. They will teach you good amount of lessons. They will teach you leadership quality. They will teach you many perspectives which you can use them in your ethical and ethics perspective. So enjoy the Holi, celebrate Holi, eat good, and drink more water as much as possible, because at present we are having, there is a more stress of, and more specifically in Karnataka, you don't have sufficient water. So drink more water as much as possible. Try to keep your body calm, cool, and composed with more amount of lemon water, lemon juices, salts, ORS, etc., so that your mind is healthy. If your mind and health are healthy, then you can absorb the things in your parts. Take care, and we'll meet up on Tuesday. Thank you. Monday there is a holiday, so Tuesday you will have a class. Tuesday you will have a class. Thank you.